I believe that the convergence of life sciences, engineering, and with clinical medicine, and I would add even mathematics, is probably the most important convergence and innovation in academic circles and in applications of the first half of the 21st century. I think, to me, that's equivalent and even more powerful than the convergence of the physical sciences, engineering, and math on the second half of the 20th century. The impact will be tremendous.
I think that we have an extraordinary opportunity here, not just because of the opportunity of MIT, but because of the community in which we live. I mean, if you think about the greater Boston area, and look at the resources that are here. You have MGH and the other teaching hospitals. You have Harvard and you have MIT. There is no better place in the world to really create the future of healthcare. And that's what makes IMES so important, is because it can play a really central role in doing that. But the key for IMES is the interdisciplinary nature and the aspect of working with other organizations, because complex biological systems are, I believe, too complex, and health is too complex really to study as silos. I think the greatest results will come from a more interdisciplinary approach, from people working together to solve common important problems. And in doing so, we ought to draw on the resources of the whole community, not just a small group of people who have been doing similar work in the past.
The thing that excites me most about this is that there are lots of institutions that are playing a role, and an important role, in bringing together biology and physical sciences, biology and engineering. In fact, MIT has been a leader in these efforts over the years, for example, through our biological engineering department, and many other things. But we have an opportunity here to take little pockets of activity where we've brought together basic science, engineering, with clinical medicine to confront human disease. And how do we integrate all of that into one whole that, in partnership with industry and hospitals, can really advance major challenges to human health and really confront them. And this excites me enormously. So think about this. We have a pandemic of neurological diseases coming up because of the aging population. That's one of the goals that IMES has, to go after neurological diseases. Another is to go after cardiovascular disease. Another is to go after infectious disease that matters not only globally, but here in our country. And a fourth goal, as we all know, the cost of healthcare is growing at a way that is definitely unsustainable in the long run. And one of the big drivers of healthcare costs going up is new innovation. Of course, new innovation has extended human life and made the quality of human life better. But we are also thinking of flipping the question around and saying, can innovation be leveraged to actually bend the healthcare cost curve?
To me, one of the things that's very exciting to me is to try to change the future of medicine. Can we bring engineering and science in new ways to change the future of medicine? Can we create new technologies that will make the world a much better place, much healthier place? And also, can we train the leaders of the future? I mean, those to me are the most exciting things, and I think that's what we are trying to do, and hopefully will continue to do.
The issues that IMES is concerned with all stem from clinical challenges. But MIT has the expertise in discovery, as well as the development of new diagnostics and devices and tools, which can try and confront these challenges and overcome them.
IMES will allow us to do very many different kinds of research. From my perspective, it's the vehicle and the platform to really push forward the moral obligation that exists in anyone who deals with patients, anyone who deals with healthcare, anyone who deals with physiology and biology. And that moral obligation is not simply to probe the depths of biology or to understand the fundamentals of physiology and pathology of disease, but to make sure that those findings have impact, clinical realization, change the way people live, change the way society is set up, and fundamentally improve the quality of all people's lives.
For us to recruit the people we want, for us to recruit the people who want to come, we need the best laboratories, and this is what we are enabling right now. And it is tremendous to have the support of people like Susan and Terry Reagan to enable us to have the facilities that will allow us to recruit and retain the best talent.
So my name is Kwang Hoon Jung. I'm a new faculty member, just joined Department of Chemical Engineering and IMES, and also I'm a principal investigator in the Picard Institute. Our interdisciplinary research team is devoted to develop and apply novel technologies for studying many neurological disorders, and we hope that our research would eventually lead to the development of new therapeutics. We have some chemical engineers in my lab who are developing chemical engineering technologies to transform a brain into a form that's transparent and macromolecule permeable, so that we can see and extract out informations in a high throughput way.
So I'm very excited about the new space that we'll be having. Space is very important, and the right space and the right infrastructure is very important, for us to conduct our research, to recruit students, to recruit other colleagues to a place like IMES or electrical engineering, computer science. In particular, I'm very excited about the space because the way that it has been laid out, it really creates communities, and it will allow me to sit next to colleagues with similar research interests. It will allow us to actually have our students sit together, and our staff, postdocs, to sit together, and me to sit with my faculty colleagues, and this way create a community of people who are not necessarily working exactly in the same area, but that creates an intellectually vibrant community that allows for exchange of ideas. Also really excited about the new spaces, that there's a collaborative space that really promotes innovation. It has room for interaction with different people, and we will have space for visitors to come and sit with us. These could be people from industry, but these could also be our clinician colleagues from across the river.
So of course, one of the greatest challenges about the space is trying to understand what we can do now for what will be needed in the future. And as of yet, I think we're really not certain about the future and the future needs. So on the one hand, I think we have to design space that's usable both for those who need wet labs and for those who don't, while at the same time creating a space that's capable of transforming over time, as the needs of the organization change. Clearly, IMES has some core group of people, and we'd like to create a space that's really special for them, a place that causes you to feel like you're within a community, as opposed to isolated, down a corridor or just off of a hall, or something like that. Personally, I happen to think color is very important. I think it has a big impact on people, and we'd also like to create an environment that when you do walk down a hallway, you see people and perhaps you say hello, and they say hello back to you. So we would like to try to do something special that people are proud to be there and enjoy being there, and creates an inviting space for other people in other locations to come and meet and discuss things.
Well, I think the promise of IMES is huge. I mean, this is really a whole institute dedicated to combining medicine with engineering and science throughout MIT. and with ties to Harvard Medical School as well.
At MIT, we're also good at growing up engineers, and there's room at the table for bringing in engineers, technologists, people who make things together with science, together with physicians, and our next generation of trainees are super excited about that. So I'm thrilled to be part of moving that forward.
I would like to say that this space, which is so critical to our development of IMES, was made possible by the generosity of Terry and Susan Reagan. And so I think not only the scientists who will occupy these labs as faculty members, but future generations of MIT students will benefit from this gift.
So I see a future where doctors are engineers, nurses are technicians, where DNA-guided diagnostics are used to create custom therapies. I see a vision in which we can cure almost any illness and repair almost any structural or organ damage. And the question is, what is it that we need to create that future? What is it we need to pioneer the science, pioneer the technology, and educate the leaders who will bring us into that future? And that, I think, is the key role of IMES.